differentiation. For implicit differentiation, what we need to do is we need to take the derivative, and we want the derivative of y. And so the problem with this particular mathematical equation, and notice I didn't say the word function, is that to find the tangent or slope of the line of the mathematical equation y squared equals x, the problem is I can't just say dy dx because it's y squared. And so I could isolate the y. Maybe I could take the square root of both sides, but then when I do that I get plus or minus the square root of x on the right hand side of the equal sign. And so that causes a problem too. And so one thing that we could do is what we call implicit differentiation. Now the nice thing about implicit differentiation is we can just kind of leave the equation the way that it is and differentiate with respect to one variable every single term, and then usually the problems are rigged up in such a way that we can find out what dy dx is. And so really what I'm looking at is the rate of change of y and x. So I would say d dx, in other words I'm going to take the derivative with respect to x of y squared and then the derivative with respect to x of x. Now when I do this, the derivative of y squared is just like x squared. I use the power rule and I would do that, but the right hand side is so easy because the derivative of x is just 1. Okay, and so but to do the derivative on the left hand side, it's just like I use the power rule, so I would say 2y, and so now here's the thing, it's 2y, but I'm taking the derivative of y with respect to x. So the 2 comes out to the front, and I'm going to subtract 1 from the power of 2. So the derivative of y squared is actually 2y, but the 2y is the derivative of y with respect to x. Okay? So now I'm solving for the derivative of dy dx. And then I have an equation here, 2y dy dx is equal to 1. Well, if I'm solving for dy dx, it seems to me that algebraically I just need to divide both sides by 2y. Now if that's the case, then I get dy dx is equal to 1 over 2y. That's it. I found the slope of the tangent line to the equation y squared equals x. And it's 1 over 2y. Now we're used to plugging in a value for x, but in this particular case we're just going to plug in a value for y, and that'll give me a slope of the tangent line at that particular y value. Any questions?